no flip, so that open ends were maxima or antinodes, and closed ends, like on a guitar string, were nodes. Okay? So, for the first one of these two, at the top, you're in air and you bounce off of water. Flip or no flip? Flip. For the second one of these, you're in water, bouncing off of air. Flip or no flip? No flip. Now, what that means is that if you had no sliding loads going along, but one of them was flipped and the other one wasn't, what would you normally get? Destructive interference. So you're going to get destructive for 0 lambda worth of shift, 1 lambda, 2 lambda, 3 lambda, etc. And how can you get constructive? Half lambda, 1.5 lambda, 2.5 lambda, etc. Everybody follow? Okay. If we see green light, what are we getting? Constructive. That means that the slide is either half lambda, 1.5, 2.5, etc. If it is the thinnest possible soap film that could give us green, then which one of these is it? The half. So what that means is that, what's the distance that you go? If this thickness is D, how far does the second wave go? Twice D. So the thinnest film that would result in constructive interference is that twice D would be half lambda. Now, we got two different kinds of lambdas. We got the lambda in air, and we got the lambda in water. Which one is appropriate to use? The one in the water. Because the medium you were in while this distance was accumulated was the soap film, or the water. So what that means is that the 2D should compare to the wavelength inside here. And the wavelength inside there is not green, but it is lambda 0 over the index of refraction.
So the lambda given is lambda 0?
Lambda given is the lambda in air, which is extremely close to lambda 0. Because lambda 0 in this expression means the lambda in vacuum. And air and vacuum are pretty darn close. So the lambda that you perceive is the lambda of air in the green. So you're going to take the lambda of 500 nanometers, you're going to divide by 1.53, move a few things around, and you will have the thickness of the film that is necessary to do it. Oh, did I say 1.53? I meant 1.33 for the index of refraction. Yeah. Yes. The reason is that this wave has to go down and back. So going down, you accumulate a distance of d, and then back you accumulate d more, so the total distance extra you've got is twice d. The 1/2 is that you have to accumulate half a wavelength worth of change in order to go to destructive, in order to go to constructive. Because it would have been destructive if you accumulated no distance. So you've got to accumulate a distance that's at least half a wavelength in order to return to constructive. So you set the twice d, which is your distance, equal to a half wavelength, and then you will have moved to constructive and you'll see the green.
How do you know you have to have constructive interference? How do you know which interference you want to have?
If you see the color reflecting off the surface,
Yeah.
it's constructive.
Okay.
If you don't see it, the reason you didn't see it was destructive.
Okay.
Question here? Okay, here, at the top surface, did you flip the phase or not? You flipped. At the bottom, you didn't flip. So what that means is that these two waves, one of them swapped crest and trough in the reflection process, and the other one didn't. So if you didn't slide them, then because one of them turned all of its troughs into crests and vice versa, then without sliding, they're destructive. So you have to slide to return to constructive. If they both did a flip, or neither did a flip, then in that case, zero slide is constructive. But because this one flipped, but that one didn't, that's why zero slide starts off as destructive. Yeah?
Not to determine flipping or flip, we did that at N1 or N2 is greater than N1, then we get a flip. And N1 greater than N2.
I couldn't hear the second half of your sentence, but here's the way I phrase it. If the thing you're bouncing off of has the higher index of refraction, you flip. Because that is like having a closed end for your wave.
So when it's
The high index of refraction is like a constriction. It's like tying down the end of the guitar string. And it makes a node by flipping the wave on the outgoing part.
I don't understand a flip.
What? Oh, here, you're in water and bouncing off of air. So air would be
Oh, okay, right.
air would be a release. So that's why there's
You're bouncing
no
off, I didn't, okay.
But here, you're in air and bouncing off of water. So when you're in air and bounce off of water, you're bouncing off of something that's a constriction, that flips the phase.
And flip just means it's a, what,
It's a 180-degree phase change.
180 degrees.
So yeah, if you have two waves and you flip one and you don't flip the other, that immediately takes constructive to destructive before you do any sliding. So in all of these problems, you have to deal with both aspects, both flipping and sliding. So you have to count each surface and decide whether you flip, and then you have to decide your slide, which could be 2D, whether based upon the number of flips, you need half a wavelength to return or one wavelength or whatever. Okay? And some people have asked me, could I give, a multi-dimensional table that has all possibilities, but I haven't figured out how to do that. So I just do it in order. Analyze the flips, then decide if you had no slide, what it would be, constructive or destructive, write this list, and then select what it is you want. Okay? So what do you think? Is this straightforward? Now, I got a question because I told this anecdote in class. If I have a soap bubble laying on the counter, the soap bubble has the water run towards the bottom, making the top thinner and thinner and thinner. And if I stand here and I look at the top of the soap bubble at a reflection of the ceiling light, what happens?
It disappears.
The reflection disappears just before the bubble pops. And the reason is, when the distance becomes nothing, or almost nothing, much less than half a wavelength, you're destructive at all colors. So you saw the reflection of a white light, and the reflection turns out like a switch before the bubble pops. Yes?
What is lambda not?
It's 500 nanometers. Yes?
So if you have like a slow-mo camera, shouldn't it do the whole rainbow? What disappears then?
Well, what happens is, I'm looking at a reflection off the top surface, and at grazing reflection, I'm not so much subject to the, how should I phrase it? If you look at okay. Okay? Everybody follow?
Yeah.
Now, if this thing is in front of me, you know what I see? Colors look like they're running down it. And the reason the colors appear to be running down is that the water is going from the top to the bottom. So the bottom of that bubble is getting thicker and thicker and thicker and thicker, and the top is getting thinner and thinner and thinner and thinner. So as you look at the top, you see these colors peeling away from it, and as the last bit of color peels away, it's like it peels away an opening, because there's no reflection at all anymore.
You usually
but you'll see it there for a fraction of a second before it pops. So you know it had to be there, because the pop is very sudden. But you'll see an opening where there are no reflections off that surface whatsoever. And that opening will last and grow before it pops. And so it's extremely cool. Yes? That's because you're now much thinner than a half a wavelength of any of the colors of visible light. So everybody is destructive. So your bubble has now become anti-reflective at the top. So you don't see reflections from it anymore. And it's just neat. It just disappears. And then it pops. Yeah. Right? Okay, so if I took two waves, and the two waves were actually a split of a single wave somehow, and I left them alone, I'd have constructive, because they were already in phase with each other. If I flip one, it'll be destructive. If I flip both, it'll be constructive. Okay? So here, I flipped one, but not the other. So that means I start out as destructive. If I had flipped both, I would start out at constructive. Okay? So I always ask myself the starting point. Count the flips and say whether I start out, which is the 0 lambda, with constructive or destructive. If I had done air, oil, and water, then I would have had flip at the air to oil, I would have flip at the oil to water, and therefore 0 shift would be constructive. So 0 lambda, 1 lambda, 2 lambda, 3 lambda would all be the constructive, and then the half lambda ones would be destructive.
So if there's an odd number of flips, you can just arrange it that way?
Yes, anytime there's an odd number of flips, you get this. Anytime there's an even number of flips, you get the opposite. Okay, what do you think?
We're done.
Soap bubbles are good? We're not done.
How much longer?
We've only been at this for 6 hours. We got 2 more to go.
Yeah. Do I have enough?
No, okay, let me rephrase this. There is more stuff on your final than we've covered so far. Would you like to continue?
Yeah.
Okay.
Do you get a 10-minute break at least?
You guys want a 10-minute break?
Yeah.
Okay, take that.
Oh, I gotta stand up. I gotta stand up. Oh! My body.